So welcome everybody to this latest video on 162 Maths, and in this video we're going over the AS Maths paper of 2020, paper 2, section B, which is the statistics section. Now as always, I'll include a question breakdown in the description below so you can see which question refers to which topic. So let's get straight into section B. So the first question for question 12 says a student plots a scatter diagram below showing the mass in kilograms against the CO2 emissions per gram per kilogram for a sample of cars in the large data set. It says their teacher tells them to remove an error to clean the data, identify the data point which should be removed, circle your answer below. So we've got choices of A, B, C or D, and the only one that doesn't go against the trend is going to be A. So that's the one that we want to highlight. Then for question 13, it says the random x is such that x is a binomial distribution with a sample size of n and a probability of a success being a third. The standard deviation of x is 4. Find the value of n. Well, for a binomial distribution, the mean is equal to np, and the standard deviation is the square root of npq, or the square root of np1 minus p, where q is the probability of a failure. So substituting the numbers in, what we get is we get n times a third times 2/3, all square rooted, and that's going to equal 4. So all I need to do is just do a bit of rearranging, work it out, and we end up with 2/9 n equals 16, so n equals 72, which is our last option. Then for question 14, it says that a retail company has 5,200 employees in 100 stores throughout the UK. The company recently introduced a new reward scheme for its staff. The management team wanted to sample the staff to find out their opinions of the new scheme. 3 possible sampling methods were suggested. So method A is you choose 100 people who work at the largest store. Method B is you choose one person at random from each of the 100 stores. And method C is that you list all the employees in alphabetical order and assign each of them a number from 1 to 5,200. Choose a random number between 1 and 52, and then choose this person and every 52nd person on the list thereafter. Give one advantage of using method A compared to method B. So for this, we want to write something along the lines of, for 1 mark, is that it's going to be a biased sample. And the reason for that is because they're only coming, so only opinions from 1 store. So something along those lines would be good enough, as one is disadvantage of method A with using method B. Then for question 14b, it says give one advantage of using method B compared to using method C. So you want to give something along the lines of that there is an equal chance of being selected, or you could say something along the lines of that it guarantees responses, or you could say something along the lines of that there's going to be representation from every store. But the key thing to remember is you're only giving one advantage, so try and make sure that your answer is only surrounded by one reason. Then says for 14ci, it says identify the method of sampling used in method C. Well, that method is a systematic sampling technique. And then it then says for 14ci, give a reason why method C does not provide a random sample. And again, reason for this is you can't select a sample size of 100, so each sample of size 100 is not equally likely to be selected so not random. So it does need to, something along those lines would be absolutely fine. The issue is the fact that you're putting the original data in some form of order, which again, for it to be randomly a random sample, again, you might find that the person with a surname of, let's say, Aaron with 2 A's is obviously therefore not going to be selected, and you want to make sure that everyone has an ample chance of being selected. Then moving on to question 15, it says that a random sample of 10 CO2 emissions was selected from the large data set. The emissions in grams per kilogram were, and it's got list our numbers, and the question then says find the standard deviation of this sample. So all we need to do is just basically enter this information on our calculators, and how we do that, so if you just go to menu, then go to statistics, then go to one variable, and then all you then need to do is enter the data, and then once you've entered it, if you then press the option button on your calculator and then go to one variable calculation, and you're looking for, as it's a sample, you're looking for the S value. Alternatively, what you could do is you could use the formula, which is sigma x squared minus sigma x squared over n, and that's all over n minus 1, all square rooted, in which you should have a answer of 22.9. Then moving on to question 15b, it says an environmentalist calculated the average CO2 emissions for cars in the large data set registered in 2002 and in 2016. The averages are listed below. The environmentalist claims that the average CO2 emissions for 2002 and 2016 combined is 145.8. Determine whether this claim is correct and you need to justify your answer. So for this, if we first of all work out what the average CO2 emissions is going to be, so that's going to be 171.2 plus 120.4 all divided by 2, and if I type that into my calculator, I do get 145.8. Now the criticism for this is that, however, the sample size for 2016 is larger than 2002, so the claim is incorrect. So something along those lines would be absolutely fine for those 2 marks. Then moving away from the large data set, thankfully, is then moving on to question 16, and it says that a mathematical puzzle is published every day in a newspaper. Over a long period of time, Paula is able to solve the puzzle correctly 60% of the time. For a randomly chosen 14-day period, find the probability that Paula correctly solves exactly 8 puzzles. So for this can be modelled by binomial distribution. So we're looking for 14. Probability of a success is 0.6, and we want the probability that x equals 8. So you can either use your calculator and substitute these numbers in using BPD on the calculator, or you could use the formula, which is 14, 8, using the NCR function. We want 8 correct, and we want, so the probability of failure is 0.4, and we want 6 failures. Now if I type that all into my calculator, I get an answer of 0.2065, and if I round that up, I get 0.207, and that's to 3 decimal places, or sig fig, whichever floats your boat. Then says Paula correctly solves at least 7 but no more than 11. So if we write this as what we're actually looking for, so x, so we want at least 7 but no more than 11. So this is the calculation that we're working at. So again, you can either use your calculator to work this out, but it's basically going to be the probability of x is less or equal to 11 minus the probability that x is less or equal to 6. So again, typing those values into the calculator, we get 0.9602 minus 0.1501. And if I take away those two answers, I get an answer of 0.810. And again, that's the 3 decimal places. It then says for 16b, state one assumption that is necessary for the distribution used in part A to be valid. So you either want to give something along the lines of that it's going to be independent, or you want to say something along the lines of that it's randomly selected, or you want to say something along the lines of that it's a fixed probability of success of solving a puzzle. And there we go. Then moving on to question 17, it says that a game consists of spinning a circular wheel divided into numbered sections as shown below. On each spin, the score x is the value shown in the sector at the arrow points to when the spinner stops. The probability of the arrow pointing at a sector is proportional to the angle subtended at the centre by the sector. Show that the probability of getting a 1 is equal to 5/18. Well, the probability of getting a 1 is the angle is 100 over 360, and if I simplify that fraction, I get 5/18. Nice and easy.
Now for question 17b, it says complete the probability distribution for x in the table below. So for x, we just got to look at the numbers that we can get. So the numbers are 1, 2, 3 and 5. So just need to write 2, 3 and 5. And the next thing we then need to do is use the angles and proportion to work out what those probabilities are going to be. So for 2, we add the two sections together. So that's going to be 60 plus 90 over 360. Work that out, and that simplifies to give me 5/12. So that's going to be 5/12 as the probability. Then for 3, well, there's two sections for that. So if we just go back, that's going to be 45 and whatever this missing angle here is, which is going to be 35. So if I just write down that as 35. Now how I've got 35 is just simply adding up all the known angles, taking away from 360, and that gives me 35. So this angle here is going to be 45 plus 35 over 360, and that simplifies to give me 2/9. And then finally for 5, well, there's only one section for 5, and that's 30, so that's going to be 30 over 360, and we simplify that fraction as 1/12.
Then moving on to 18a, it says that a bag A contains 7 blue discs and 4 red discs and 1 yellow disc. 2 discs are drawn at random from a bag without replacement. Find the probability that exactly one of the discs is blue. So again, there's a number of ways in which we could do this, but you can either do a tree diagram if that helps you, or you could do it without using a tree diagram. But the possible options are blue, red. We could have blue, yellow. Then we could have red, blue, or we could have yellow, blue. So working out the probability of a blue, red, well, that's going to be 7/12 times 4/11, which equals 28/132. Blue, yellow is going to be 7/12 times 1/11, which is 7/132. Red, blue is going to be 4/12 times 7/11, which is 28/132. And yellow, blue, which is 1/12 times 7/11 equals 7/132. Then the only thing that's left for me to then do is add those four probabilities together, in which I get 70/132, which simplifies to give me 35/66. Then moving on to 18b, it says that bag A contains 7 blue discs, 4 red discs and 1 yellow disc. Bag B contains 3 blue discs and 6 red discs. A disc is drawn at random from bag A and placed into bag B. A disc is then drawn out of at random from bag B. Find the probability that the disc drawn from bag B is red. Now for this, probably maybe best to draw a diagram, a tree diagram for this. So we've got 3 possible options in which I've got blue, I've got red, and I've got yellow. Now from this, I could either select a blue or a red, blue and a red, and a blue and a red. Now from this, what I can then do is, now bag B doesn't have any yellow discs, so that's going to be absolutely fine. So in terms of looking at this, well actually that one's going to have a yellow, so we'll just add that in, and this is bag B. So then filling in the probabilities, we've got 7 over 12, then we've got 4 over 12, and then for yellow we've got a 1 over 12. Now if I've selected a blue one and put it into this, I'm going to have 1 extra one, so that's going to give me 4 out of 10, and the red is going to be 6 out of 10. Then if I select a red one, I'm still going to have, well, I'll have 3 there, and I'll end up with 7 there. And then if I select a yellow one and put that into bag B, I'll have 3 blue out of 10. I'll have 6 out of 10 for red, and I'll have 1 out of 10 for yellow. Now in terms of the probability that a red disc is drawn, well, it's either going to be this, that, or sorry, not that one. It's going to be this one here, or it's going to be that one there. So it's going to be 3 of those, one of those 3 options. So then from this, looking at this option here, well, that's going to be 7 over 12 times 6 over 10, which is 42 over 120. This here is going to be 4 over 12 times 7 over 10, which is 28 over 120. And this one here is going to be 1 over 12 times 6 over 10, which is 6 over 120. Then if I add those 3 probabilities together, I get an answer of 76 over 120, which simplifies to give me 19 over 30. Then moving on to question 19, it says that it is known from a historical data that 15% of the residents of a town buy the local weekly newspaper, Local News. A new free weekly paper is introduced into the town. The owners of Local News are interested to know whether the introduction of the free newspaper has changed the proportion of residents who buy their paper. A random sample of 50 residents from the town are taken after the free newspaper was introduced, and it found that 3 of them purchased the Local News regularly. Investigate at a 5% SIG level whether the sample provided evidence that the proportion of local residents who buy Local News has changed. So for this, let's first of all set up our 2 hypotheses. So the null hypothesis is that the probability of them buying the paper is still at 0.15, and for H1 we're looking to see if that has changed. So it's going to be a 2-tail test at a 5% SIG level. Now looking at the parameters of this, we know it's going to be binomially distributed with a sample size of 50 and the probability of a success being 0.15. Now my test statistic is going to involve something involving 3, so it's probability that x and 3. Now I just need to decide whether it's going to be less than or more than. Now to do that test, what you do is if you multiply n times p, so that's going to be 50 times 0.15, and that gives me an answer of 7.5. Now as 3 is on the left of 7.5, my test statistic is going to be less or equal to 3. So then from this, if I then enter this on the calculator, it gives me a value of 0.0460467.
So now that I've got my test statistic, all I need to do now is to write up the conclusion. So if I just start by writing conclusion, so using the test statistic, which we got as 0.046, we've got as, oh, don't know what I've done there. So as 0.046 ... is greater than 0.025, because remember it's a two-tail test. Now how I usually define that is if I draw my little diagram. Now again, it's not, although this is not normally distributed, this is a diagram that I tend to draw. We've got a two-tail test, so this is the 2.5%, there is a 2.5%, and so this number here is 0.025, and this number here, if we think about it as a scale, then that's going to be 0.975. Now my test statistic, now this middle bit here is my HO region, that's where I accept HO, and these little two small bits of areas on either side, as it's a two-tail test, are my where I accept H1. So look, using the lower limit, because obviously our test statistic is lower than NP, we can see that 0.046 is going to be somewhere here. So that's 0.046, and that is in our accept HO region. So here what we're going to then do is we accept, if I can spell it, accept, that is a C. Actually, let's write that a little bit clearer. So we accept HO or reject H1, whichever floats your boat in terms of your conclusion. And then we just need to write a closing statement of that sufficient evidence suggests at a 5% sig level that the proportion of people buying local news has not changed. And again, when doing any hypothesis testing and your conclusion, it's always important that you do say that the sufficient evidence testing at a 5% sig level. Always remember you're including that significance level in your conclusion, and then stating what that actually means in real life. And that concludes the end of this walkthrough.